Hello everyone. Review for the quiz. The first 4 questions are non-calculator. So we have 4 non-calculator. And there are, I think, 13 or 14 questions total. Now this first question is a graph. It says to include all these things, but they're not graded. Your graph will be graded, if that makes sense. So you don't have to mention or specifically write down the details, but these are the details that I will be looking for on the graph. So I put them in the directions just to make you sort of extra mindful of those. So your x-intercepts, your x-intercepts are going to be x equals, got strugs here all of a sudden, x equals 0. That's going to be a slide. You can write it. You don't need to write it, whatever helps you. We're going to have x equals -2. That's going to be a bounce. X equals 2 and x equals -4. And again, you don't have to write those out. I've written them down. You could go straight to the graph and just put them right on the graph. Whatever works for you. And then, of course, the y-intercept, if you plug a 0 in there, you get 0. So our y-intercept is 0, 0. That's already on the graph. This is the degree, 3, 4, 5. So this would be x to the 7th. So it is odd and positive. And so we know that odd and positive means this end would go up on the right. Wait, I feel like I might have added that wrong. 3, 5, 6, 8. My fault. X to the 8th. So both ends go up because it's even and positive. Now, you are not to find any additional points. You do not need to worry about calculating additional points, so we're going to have some guessing here. So we know at 2, it goes straight through. There is a slide at 0, which means it should sort of go horizontal for a second, right through 0. And we have a bounce at the other 2 points. So it goes up however high you want to. It bounces at -2. Again, however high you want it to go to, and it bounces at -4. There's several questions like this that ask you about just the theory of the roots and explaining different parts of roots. So if we have a 4th degree polynomial and we have -3, I'm writing it out because it's hard to read, 1 plus 2i and 1 minus 2i. We already know these are the roots. We're clearly missing one. But the imaginary, we already have both of them. So we do not have enough information to write the polynomial. Both complex roots were already there, or both imaginary roots already given. But if one was missing, you could come up with its conjugate and be able to come up with that missing root. Now, in terms of the polynomial inequalities, there is one question like this on the quiz. So all of this stuff is on the quiz. It's just not this many. So for this first one, we got to set equal to 0, so put it in order. GCF of just plain x, so we're left with x squared plus 2x minus 3. Factor it again, x plus 3, x minus 1, and our answers are 0, -3, and 1. So what this means is you cannot use 1, you cannot use 0. I'm going to go with 2. And x equals 2 lives over here. Plugging it back into the original, 2 to the 3rd, 8. 2 times 4, that's an 8. And then is that greater than or equal to 3 times 2, which is 6. So yes, that's true. Of course, there's a line under it. So that means this one works. So remember, it goes no, or yes, no, yes, no. And interval notation is how you write your answer, and even has that in the directions to sort of help you remember. So we have -3 to 0, and also the interval from 1 to infinity. In number 4, getting this thing set equal to 0, put it in the right order as well. So 2x to the third minus 3x squared minus 32x. The 48 stays where it is, and now it's equal to 0. Grouping, anytime you have 4, it's grouping. So we have x squared, and then we're left with 2x minus 3. These two have a negative 16 in common, 2x minus 3. And now we have 2x minus 3 as the common factor, x squared minus 16 as that second factor. Here we get x equals 3 over 2, and there you get x equals plus or minus 4. So on the number line we have negative 4, 1.5, that's 3 over 2, and positive 4. I'm going to try x equals 0. That lives right here. And so we would get 0 on all those spots. So we end up with 48 is less than 0. Well, that's of course not true. So that section doesn't work. No line under this symbol, so these are open. And we know that this section works, so it goes yes, no, yes, no. And then of course the interval notation, negative infinity to negative 4, and then from 1.5 to positive 4. So those are your first 4 non-calculator questions. And then we get to the calculator part. Now there are 2 questions that involve graphing, evaluating a function, finding some sort of cubic, quadratic, quartic, whatever it happens to be. And some of them involve maximums, some of them involve finding the answer to a question like you'll see here, 6, 7, and 8. So it's a variety of questions, but there are 2 problems. One where you're given the table, like this one, and one where you're given an equation. And you're asked to find some things. So they're non-related, 2 different questions, but you have to do this 2 different ways. So the idea is that you can manipulate your calculator pretty quickly and accurately. Now for number 5, it says quartic. When you hit calculate the quartic regression, your coefficient for your x to the 4th comes out as 1.33 times, and it's times 10 to the negative 4th. It's an e, which is your calculator's way of saying scientific notation. So when we go to do this, you got to move this over. 1, 2, 3, 4. So even though I'm asking you to write it for 3 decimal places, it's not going to be enough. So this coefficient is super awkward. So it's a decimal point, 3 zeros, 1, 3, that's probably good enough, x to the 4th. After that it gets a lot easier, minus 0.012 x to the 3rd plus 0.26, that's not even rounded, it's just plain old 0.26 x squared minus 0.393 x plus 2.952. Now make sure you go to y equals and put that into y equals, or store your regression equation. Either way, you've got to make sure it's in there. Based on the data and the questions, I made my window for x I made it from 5 to 40, and the y I made actually negative 5 to 40, and then I made my y's kind of the same way. I think I went negative 10 to 40. You don't really have to go very far. I went pretty far left to right because I wasn't sure how many days out it would happen. It looks like it happens within 23 days, but I just went to 40. It was plenty. What day will the number of students be at the maximum? This is just second. Calculate the maximum. It's about day 19. If you want to give an exact answer, that's up to you. For the next problem from number 7, you'll have your graph. It kind of looks like this. And then you graph y equals 18 and find your points of intersection. I did this 3 or 4 times. I got answers that were, first side was close to 12. I got 11.91, so I got 12.21, so I got some other different answers, but they're right around 12. My other end, I got a lot of different answers. I got 25.5 once, I got 26.2, I got 26.3, I got a lot of different answers here. So I just called it right around 26. And because of your windows and how your window is set, or where you put your left and right bounds, your answers can vary, and I understand that. So don't worry about, oh, I'm just slightly off. Now, my answer is 12 to 26. You shouldn't have an answer like -5 to 400. It should be within 1 or 2 numbers on either end. It should be close. When will the number of affected students drop to 0? This means the second 0. So your graph comes back down there, not the first 0, which is on the negative end, but the second 0. And again, I got a couple different answers. I got 33 days. I also did it a different time. I got 32 days, but those are really close together. And so if that happens to you, that's no problem at all. All right. Factor when find the x-intercepts. There are 2 of these. Pay attention to the directions. They may say find the real, may say find all. So you want to make sure that you read that carefully. For number 9, we've got factor by grouping because it's 4 terms. First 2 have an x squared in common, leaves you with x plus 5. Second 2 have a -9 in common, again leaves you with x plus 5. Here we're only looking for the real. It looks like we're going to get a whole bunch of them though. We're going to maybe get all 3. And so we get x equals plus or minus 3 and x equals -5. For number 10, you're going to have to memorize this pattern. It's the only way to know how to factor it. Cube root. Cube root is 64. Now you'll have your calculator, so you could use your calculator there. Square it, multiply them together, and square the 4. This is your SOAP. So same, opposite, and positive. Now we already know that this part will not result in a real solution, so you don't even have to mess with it. And so when you go to set this equal to 0, we only get one real solution. So if you ever get stuck, you can always verify by looking at your calculator. You can look at the graph. I mean, you'll have your calculator. Try to use your resources wisely. Now for number 11 and 12, we're trying to find all of the zeros. So that means imaginaries, whatever else we can find. So again, grouping. So these first 2 have an x squared in common. The next 2 have a positive 9 in common, leaves you with 4x minus 1 again. So now we have 4x minus 1 and x squared plus 9. The idea is at this point, when you have a plus in this 2 squares, you're going to have imaginaries. A minus in 2 squares, you're not going to have imaginaries, and that's really the only difference. So we get 4x equals 1, x equals 1/4. Here we get x squared equals -9, and that's how you get plus or minus 3i. And the last factoring, again, really these are just here for practice. Obviously there's not this many. GCF of x squared minus 3x minus 28. Don't forget about that x squared. It gives you answers, so don't just drop it. 7 times 4 is 28, and -7 plus 4 is -3. So here we get x equals 0. That is a double root. You don't have to say that, but when considering all of your answers, you know that counts as 2. Then we get 7 and -4. So there's all 4 of them. Here's another question kind of about the same deal. Now, this was a typo. Apologize for that. This said multiplicity of 12. Doesn't make a lot of sense. So we have a 4th degree polynomial that has 1 0 with a multiplicity of 2. So much like number 12, right? Just kind of like number 12. 4th degree, multiplicity of 2. What is the maximum number of different zeros? Well, here I said number 12 is a really good example. The maximum would be 3 different zeros because one of them is used twice. So that means we can only have 3 unique solutions because one counts the same one twice. 14, definitely on the quiz. Possible rational roots. This is your P over Q. If it doesn't say possible list, possible rational roots, don't bother with P over Q. It's not something you have to do all the time. You just have to do it once. Plus or minus 1, factors at 12, 3, 4, 6, and 12. Then you go to the calculator. Whether you look at the graph or the table, it's up to you. You get two solutions. You get x equals -3 and x equals 1. So you got to use synthetic division. You don't get any others. There's no double roots. There's no bouncing. They go straight through. So I'm going to start with 1. Please make sure you have all of your coefficients, x to the 4th, x to the 3rd, x squared, plain old x, and x to the 0, your constant. Bring that first term down and multiply. So we'll multiply the little box times under, push it forward, add. And then start over. 1 times 3 is 3, and you always add. 1 times 4 is 4, add. 1 times 12 is 12, and you should get a 0. The calculator told you it was 0, so please make sure you get a 0. Now we do this with the -3. Bring down the 1. Don't stop there. You've got more numbers to the right, so keep going, even though you got a 0. And then we get -12. This is a 0. So now we have to go back and figure out, well, what is this? Where are we? This started off with x to the 4th. That was the original. Underneath the line is x to the 3rd. And underneath the line is x squared. That's x. There's your equal sign. That's a plus. So you can see that we are left with x squared plus 4 equals 0. So x squared equals -4. And our other two answers, x equals plus or minus 2i. So we have all 4. Now, for numbers 15 and 16, there's only one of these. Might have imaginaries, might not. Tedious. So after the embedded assessment, obviously you know how tedious these are. We're missing one. All right? If they give you the 3i, then you know -3i as a root. So we have x plus 1, x minus 3i, and x plus 3i. You have to do the imaginaries together, leaving you with x squared minus 9i squared. I squared is -1. So this comes out and we put in a -1. So we're left with x plus 1 times x squared plus 9. Please finish the problem and multiply this out. You get x to the 3rd plus x squared plus 9x plus 9. That is in standard form. Looks like I might need some more space for number 16, so make this a little bigger here. Now, degree 4, no imaginaries. They gave us all 4. When it's 0, that means it's a plain x. And then we have x minus 1, opposite x plus 2, opposite x minus 3. I'm going to multiply the first two together and the second two together, so you get x squared minus x. The second two, you get x squared minus x minus 6. I can't multiply more than 2 together, so I thought I would do 2 and 2. And now, of course, my shortcut's done. I'm going to take this x squared times these 3, and then I'm going to take the -x times those same 3. So we get x to the 4th minus x to the 3rd minus 6x squared. I'm done with the x. Now I'm going to go with the x squared. I'm going to go with the -x. So we get -x to the 3rd plus x squared plus 6x. Combining like terms, highest power, x to the 4th. There's 2 of these, so minus 2x cubed. X squareds are minus 5x squared plus 6x. No constant. Definitely one of those on the quiz. Last page. Please look at the directions before you start going crazy. There's one of these on there as well. Factored form, factored form. Just look for it on the quiz so you don't have a lot of work to do. fourth degree, and we only have 3 roots. So we would have x plus 2, x minus 4. Now, if 2 minus 3i is a root, then 2 plus 3i is a root. We're not multiplying this, we're just writing it out. You would have x, it's always minus, x minus, and then in parentheses, 2 minus 3i. And then the last one would be x minus, in parentheses, 2 plus 3i. And it says factored form, so you can leave it like that. Don't even have to get rid of the double parentheses. Now, from the picture, you're going to have to do a little counting. This is -3, -6. There's a 1. This is a 4, and that's a 7. All right, so now we got the numbers. Be a little bit easier to write this. X plus 6. The idea is you can look at it and you can see it's bouncing. That's the power of 2. X plus 3 has a slide, so that's a power of 3. And the powers go all the way on the outside of the parentheses. X minus 1 goes straight through, no power. And the next two bounce. I'm running out of space. I'm going to do x minus 4, quantity squared, and x minus 7, quantity squared. That's a minus. And again, don't multiply that out. It says factored form. You've already done all the multiplying or the embedded assessment. So that is the whole quiz. Come by during E&I. If you need any help, if you have any other questions, please let me know.